The product of A dot B cross C is what's known as a scalar triple product of the vectors A, B, and C. Now, its geometric significance can be seen in the volume of a parallelepiped. Let's draw a quick picture here. So, let's see, I'm going to have an axis. Well, actually, let's just start drawing the geometric figure. If this is, say, vector C, and this is vector B, and then up here I'm going to have vector A. Now, I can draw, based on these three vectors, this geometric figure. Let's see. And this is going to come down here. I'm going to be over here. Yeah, that's the idea. It's basically this cube that every side of this cube is a parallelogram, although it doesn't really look like it over here very good, but I think you get the idea. And I'm going to have an axis here, and I'm going to refer to this angle here as theta. Now, when we look at this, the volume is the area times height. So the area of the base times the height. Well, the area is B cross C, these two vectors B and C. If I take B cross C, that will give me the area of the base parallelogram. And when I look at the height of this parallelepiped, that is going to be the magnitude of A times cosine of theta. So this is actually the height, and this is the area of the base. So what this amounts to, when I reorganize these, I have the magnitude. Remember that B cross C is also a vector. So I take the magnitude of this vector, the magnitude of this vector times cosine of theta. That's the definition of a dot product. So really all I'm doing is I'm taking the dot product of a vector, and B cross C is actually another vector. So this is actually just the cross product of two vectors. Now also notice that I can write this volume a couple different ways. I say volume equals the magnitude of A dot B cross C, which is what we have. But we could also write this as C dot A cross B. Obviously all of these are vectors, which obviously I could also write as B dot what's left, C cross A. Because if I take B cross C, that's going to give me the area of that guy. A cross B is going to give me the area of this side parallelogram. And then the height is going to be if I take this axis out this direction, theta would now be over here. And then C cross A, that would be the area of this parallelogram that's up here. And then I dot it with B. So basically I can pick any one of these parallelograms based on these three vectors and find the area of that parallelogram, multiply it by this height, and the height is going to change, and I will get the volume of this thing. So what's kind of neat about this is we can actually use this result to determine if three vectors are coplanar or not. Because if they're coplanar, meaning they're all on the same plane, then the volume would definitely, or obviously, be 0. Because in that case, if they're in the same plane, there is no height. So as a quick example, let's take a look at these three vectors, u, v, and w. And I want to determine if they are in fact coplanar. So that says find the volume of the parallelepiped. If it is non-zero, then these vectors are not coplanar. If it is 0, then it is in fact coplanar. So what I really want to find here is u dot v cross w. Obviously the magnitude, but it's not going to be relevant here because all I'm looking for is, all I'm concerned about is whether it is 0 or non-zero. So I'm going to start off with taking a look or finding v cross w. So I'm going to set this up in a matrix. And I will get 3, -1, 0, and 5, 9, -4. And now I'm going to look for the determinant, and that's going to be -1 times -4 minus 9 times 0, so just minus 0. And that's going to be the I component. Minus, remember the pattern, plus, minus, plus. Minus, now I'm going to take a look at j, so I have 3 times the -4. Minus 5 times 0, so that's again minus simply 0. That's j. Plus, this last component for k is 3 times 9. Minus 5 times a -1. And that's the k component. Well, if you go ahead and finish up the arithmetic, you get 4i plus 12j plus 32k. So what I end up with is this vector 4, 12, 32. So now what I need to find is, and this vector, so you understand what's going on, that's the vector produced by that cross product. So what I need now is that to find the volume, which is in this case is going to be u dot v cross w. That's supposed to be a v, which is going to be 1, 5, -2 dot 4, 12, 32, which is going to be, let's see, that's equals 1 times 4 plus 5 times 12 minus 2 times 32, which is 4 plus 60 minus 64. I guess I really should have the magnitude of this, but like I said, really all I'm interested in is whether this thing is 0 or non-zero. And this is 0. Therefore, we can say these three vectors are, in fact, coplanar. Now, I want to show you how to do this quickly using Maple, because it's a nice way to check your work. So I'm going to jump into Maple, and I'm going to start with linear algebra. And when you do that, linear algebra needs to be capitalized. And I'm going to end it with a colon so I can suppress this output because I want to see. Well, actually, you should probably see it real quickly. See, there's a bunch of commands that I just brought in. Okay, so I have the with linear algebra. Now I'm going to define my vectors. So u is equal to the vector. What was u? That's going to be 1, 5, -2. V is the vector 3, -1, 0. And W is the vector 5, 9, -4. So I'm going to define another vector. I'm going to call it just vector A. And A is going to be the vector that's the result of the cross product. So I'm going to ask for the cross product of V and W. And that's 4, 12, 32. Notice that's the same thing we got when we did it by hand. Now what I need is the dot product of U and A. And that's 0, so that confirms the volume is 0, so these vectors are in fact coplanar.